Okay, so our next topic is all about functions and relations and graphs. And before we do get into anything, I want to make sure that you are comfortable with function notation, because I want to be able to talk in terms of function notation about everything that we do from this point forward. In particular, I want us to really be able to start to generalize some of the transformations we're observing with graphs and to talk about those in the context of function notation. And so before we get into that, before we then get into introducing all the new graph shapes, we just want to make sure, I just want to make sure that your function notation is reasonably sound. So function notation is an efficient notation to use when we work with functions. It's really easy to indicate that you want to substitute something into a function, or you want to solve a function equal to something else. It ultimately means that you have to write down less because you've got this shorthand for referring to your functions. The second reason it's so important is in terms of using your CAS calculator. Your CAS calculator works really well with function notation. When you sketch a graph, it automatically defines that function, and therefore if you understand function notation, you can really quickly and easily find key points and features of your graph in the calculator screen using the function notation, rather than mucking around with lower bounds and upper bounds and all that sort of thing in the graphing screen. So when we talk about any function, we can always think about a function as having input and output. Okay, probably right back at the beginning of your algebra journey in sort of year 7 and 8, you probably learnt about, simple linear function as a sort of input-output kind of machine. So for example, if our function is 2x plus let's say the function is 2 times the input, plus 3, then if our input is x, then our output is 2 times that input plus 3, okay? And so that would mean that if our input was the number 2, we would do our output f of 2, applying our function f to the input value 2, would be 2 times 2 plus 3, which is 7. If our input value was -1, then our output would be f of -1, applying function f to -1, and function f says that you take 2 times the input and add 3 to it. And so in this case, that would be -2 plus 3 is 1, okay, etc., etc. So we want to think about it in this way. So often we call the sort of y values we think about the y values as being the output of the function. So when we use function notation, we don't use a second variable y, we simply talk about the output as being a result of applying the function to the input. So f of x, do function f to x. Do f of 2 meaning do function f to 2. F of -1 meaning do function f to -1. Okay? So if the function f is called f and the input is x, then the output would be f of x. Okay? If the function is called g and the input is x, so the function doesn't have to be called f, it could be any letter. If the function is called g and the input is x, then the output would be g of x. We're applying function g to the input values, which are called x. If the function was called f but the input was t, then the output would be called f of t. We apply function f to the input values, which are called t. Okay, so just being clear about how we read that and how we understand that. So if we have a look here, we've got a different function still called f, and function f is when we multiply the input by 3 and then add 4. So here, if our input value is x, we put it into the function. The output is a result of applying f to the input x, f of x, and it is 3 times x plus 4, 3 times the input plus 4. Okay. If our input is 2, we apply it to the function, the output is f of 2, and it is equal to 3 times 2 plus 4, which is 10. Okay. If our input is 5a, we put that into the function. The output is then called f of 5a. We've done function f to the input 5a, and function f means we triple and add 4. 3 times 5a plus 4, which is 15a plus 4. Okay. If our input is x squared minus 2x, we put that into function f, which means we are doing f of x squared minus 2x, and that is take x squared minus 2x, multiply it by 3, and add 4 to it. And we can see here, we tidy that up and simplify it, and we get 3x squared minus 6x plus 4. Okay, so let's complete the following tables. So if our function called g is the sum of the square of the input and 5 times the input, well then when the input is x, g of x, the result of doing this to x, is the sum, x, so we're adding, of the square of the input, so x squared, plus 5 times the input, so 5x. So g of x is x squared plus 5x. If our input is 2, our output is going to be called g of 2. We're doing function g to the input value 2. And that means that we square 2 and add it together with 5 times 2, which is 4 plus 10, so 14. If our input is negative 3, the output is g of negative 3. We do function g to negative 3, which means we take negative 3 and we square it and we add it together with 5 times negative 3. Now negative 3 squared is positive 9. Minus 15, so that's going to be negative 6. If our input is x plus 1, our output is g of x plus 1. We do this function, we take the sum of the square of the input and 5 times the input to the input value of x plus 1. So that means we're going to have x plus 1 all squared plus 5 times x plus 1. And we can tidy that up. X plus 1 all squared is x squared plus 2x plus 1. And expanding out that second bracket is 5x plus 5, and so it's x squared plus 7x plus 6. Function h, a different function called h, is the square root of 10 minus the input. So if the input is x, h of x, doing function h to x, is taking the square root of 10 minus x. Square root of 10 minus the input, and the input is x. If the input is 1, h of 1, doing h to 1, means square root of 10 minus 1, which is square root of 9, which is 3. Please note that the square root of 9 doesn't equal plus or minus 3. Okay, in the same way that 5 does not equal plus or minus 5. Okay, if we've got the positive square root of 9, there's no minus written out here or plus written out here. When there's no sign in front of a number, it's positive. Okay, so this is the positive square root of 9, which is 3. If you are solving x squared equals 9 and you have to take the square root, there are two possibilities for what 9 could be. Okay, but if you are just given the value root 9, it is the positive square root of 9. If you're given negative root 9, it is the negative square root of 9. Okay. So root 9 is positive root 9, which is 3. If our input is negative 5 and we apply function h to that input value, so that is we take the square root of 10 minus that input, square root of 10 minus negative 5, we call that h of negative 5. Okay, so it's square root of 10 minus minus 5, which is square root of 10 plus 5, which is square root of 15, which is a third in simplest form. If our input is 3a, the output is h of 3a, applying function h to the input value 3a, and it is the square root of 10 minus 3a. Okay. If our input is x plus 4, our output is h of x plus 4, applying function h to x plus 4, and it is 10 minus, careful about the brackets here, the input, 10 minus x plus 4, which means it's the square root of 10 minus x minus 4, which means it's the square root of 6 minus x. So we do want to give our answer in simplest form, so just collecting like terms or simplifying surds if possible, etc. Okay, let's have a look at this question here. So we've got two functions, f of x, which is a quadratic function, and g of x, which is a linear function, and we want to answer these questions. So we want to find f of 0, okay? So that means we want to, we are now making the input of the function 0. So in place of x, the function is going to have 0. So it's going to be 0 squared plus 5 times 0 plus 6. So 0 plus 0 plus 6, which is 6. Now, I want you to not worry about this notation for now. We'll look at what that means a little further down the track. Essentially, let's just focus on what this means. We want to, technically what we want to do is find x where f of x is equal to 0. Okay, so if f of x equals 0, this is f of x. Okay, that whole thing, that is f of x. And so we want to make that equal 0. So x squared plus 5x plus 6 equals 0. And then we want to find x. and so we can solve that. It factorizes to x plus 2, x plus 3 equals 0, and so therefore null factor law tells us that x plus 2 equals 0, which means x equals negative 2, or x plus 3 equals 0, which means x equals negative 3. Okay, part B. So it's really important that you understand the distinction between f of 0 versus f of x being equal to 0. Here the input is 0, here the output equals 0. The y values are 0. Okay, it's a very different thing. I find students sometimes struggle to distinguish between those two things. In part C, again, let's ignore this notation. Essentially it means find x, where g of x is equal to 0. Okay, so let's focus on g of x. G of x is equal to that, and so therefore that has to be equal to 0. 3x plus 14, which is g of x, has to equal 0. So we want to find x. 3x is negative 14. X is negative 14 on 3. Again, let's ignore the notation around it. We want to find x where g of x is bigger than 5. So again, g of x is 3x plus 14. So 3x plus 14 is bigger than 5, and we want to solve this inequality for x. So we want to take away 14, which means 3x is bigger than negative 9, and we want to divide both sides by positive 3, so we don't inverse or turn around the inequality. We're just dividing both sides by positive 3, and so x has to be bigger than negative 3. Again, let's ignore that notation around it. Let's focus on the equation. We want to find x where f of x is equal to 0. So f of x, we know, is x squared plus 5x plus 6. And, sorry, not equal to 0. F of x is equal to g of x. F of x is x squared plus 5x plus 6. And g of x is 3x plus 14. So we have x squared plus 5x plus 6. And that has to equal 3x plus 14. And we want to solve for x. So subtracting 3x from both sides is x squared plus 2x, and subtracting 14 minus 8, that factorizes. Factors of negative 8 that add up to positive 2, x plus 4x minus 2. And then null factor law tells us that x plus 4 has to equal 0, so x equals negative 4, or x minus 2 has to equal 0, so x equals 2. Okay, so again, just being really clear about the difference between sort of f of 1 versus f of x equals 1. Also understanding that if g of x equals 0, the whole function has to equal 0, so 3x plus 14 has to equal 0. F of x could equal g of x, in which case the two functions are equal to each other, and then we solve for x. Okay, let's solve some problems involving function notation. So here we want to find a linear function f such that f of 1 is equal to 5, and f of negative 2 is equal to negative 1. So this is telling us that for this function, when the input is 1, the output is 5. So the graph goes through the point 1, 5. This tells us that the graph goes through the point negative 2, negative 1. When the input's negative 2, the output is negative 1. So we want to find a linear function, and we've been given 2 points. Okay, so we want to find, for a linear graph, we need to find the gradient. Okay, so gradient is rise over run, 5 minus 1 over 1 minus 2. So that's 5 plus 1, which is 6, over 1 plus 2, which is 3. And so the gradient is 2. And then we can use either of our points to find the equation of the line. I personally prefer to use y minus y1 equals mx minus x1, but you can use y equals mx plus c if you prefer. Okay, so y minus the y coordinate of the point, y minus 5, equals our gradient times x minus the x coordinate of the point 1. So I've chosen to use this point along with the gradient. You could use the other point if you prefer. Now just tidying up and making y the subject, so expanding the brackets on the right hand side is 2x minus 2, and adding 5 to both sides, the equation is 2x plus 3. Let's answer the question, which asked us to find a linear function called f, and so therefore f of x is equal to 2x plus 3. And you should be able to verify. If you find f of 1, it's 2 times 1 plus 3, which is 5. Good. If you look at f of negative 2, it's 2 times negative 2 plus 3. 2 times negative 2 is negative 4 plus 3 is negative 1. So indeed, that one is also true. Okay, so I'm just getting rid of that. If you had used y equals mx plus c, no problem. You put your gradient in, then you sub in your point. If you put in the 0.15, y equals 5 when x equals 1. Oops, sorry, not equals c, plus c. So 5 equals 2 plus c, so c equals 5 minus 2, which is 3. And so therefore, your function is 2x plus 3. Okay, so whichever version you prefer, that's fine. Okay, example 4. Find the quadratic function g such that g of 0 is the same as g of 6 and they are both equal to 0. Okay, so this tells us that g of 0 equals 0 and g of 6 equals 0. Okay, so this means that when the input is 0, the output is also 0, so the graph goes through the origin. This means when the input is 6, the output is 0, and so the graph goes through the point 60. They are both x-intercepts. So finding the equation of a quadratic when we have the x-intercepts is probably best to start with a factorised form. However, if we think about the third bit of information, we know that -3 is the smallest value of g. So what we now know is that we have a parabola which has a smallest value, so it's going to have to be a happy parabola. Goes through 0, 0, it goes through 6, 0, and the smallest value of that function is -3. So the y-coordinate of that point is -3. We actually also know the x-coordinate of that point because it's halfway between our two x-intercepts, and so it's at 3. So we actually have both the x-intercepts and the turning point. So you could start with the x-intercepts if you want. A times, well, it'd just be x for the x-intercept at 0 times x minus 6, and then sub the point 3, -3 to find a. Or you start with turning point form, y equals a times x minus 3 all squared minus 3, and then sub either 0, 0 or 6, 0 to find a. Both will give you exactly the same solution. Perhaps let me just work through that for both of them just so that you can see that we get the same thing. I just haven't got a lot of room here. Let's just take this one over here and this one up over here. Oops, lost the y. Okay, so let's sub 3, -3. Just going to move that over so we've got room. Okay, so y equals -3 when x equals 3. So it's -3 equals a times 3 times -3. -3 is -9a, and so a is positive 1/3. Okay, and so therefore our equation is called g. We're finding function g. So therefore g of x is 1/3 times x minus 6. Or if we used our turning point form up here, just let me move that up and over a bit more. We're going to substitute the point 0, 0. So you can't, because we used the turning point in this form to come up with turning point form, you can't sub that point in because all it will tell you is that -3 equals -3, which is correct, true, but useless. Similarly, in this form, we used the two x-intercepts to come up with that general form, and so then we can't use either of those to sub in to find a. We have to use the turning point. So I could either sub 0, 0 or 6, 0. 0, 0 looks a bit easier to me. So it's a times -3 squared minus 3. I'm going to add 3. A times 9. And so a is 3 on 9, which is 1/3. Okay. And so therefore, the function g of x could also be written as 1/3 times x minus 3 all squared, take away 3. Obviously, you could also expand out and have it be 1/3 x squared minus 2x. Would also be a third correct way of describing g of x. So any of these three things, g of x equals that, g of x equals that, or g of x equals that, would be correct equations for this particular parabola. Okay, example 5, our final example here. Write p of x in the form this, and hence state the range of p. Sorry, I meant to get rid of that question. I'm going to ignore question 5 for now. I think I've included it later in the notes. My apologies, I didn't edit this. We'll talk about what the range means down the track. So for now, let's have a look at exercise 5C, just questions 5, 6, 7 and 8, and then exercise 5F, all of those questions.